We'll determine the relationships between each pairs of structures here. We're either going to declare them as the same structure, enantiomers, or diastereomers. Remember that enantiomers are going to be mirror images, non-superimposable mirror images, whereas a diastereomer is going to be your other. And diastereomers really come about when you have more than one asymmetric center. When you only have one asymmetric center, you're either going to look at they're either the same compound or they are enantiomers. When you have a compound that only has one asymmetric center, it might be easiest to just name them. Name the R and the S of the asymmetric center. So here I have an H pushed to the rear and I'm rotating clockwise. This is an R and this would be named R2-chlorobutane. For this asymmetric center, again, chlorine is 1, we have the ethyl group is 2, and the methyl part is 3. We are rotating counterclockwise, so this would be S2-chlorobutane. So these are enantiomers. 52, going to name them again, and this is going to be my R. And here is going to be, this is the same molecule as what I had over here. So this is R2-chlorobutane. And over here, chlorine is 1, ethyl is 2, methyl is 3. These are actually mirror images. This goes counterclockwise. This is an S, so these are enantiomers as well. In fact, these are the same compounds. Here we have, again, our R2-chlorobutane. And here our chlorine is 1, the ethyl group is 2, methyl group is 3. The H is coming out towards us when we're rotating clockwise. So this is S2-chlorobutane. So these are enantiomers. Same. Here we have, again, our R2-chlorobutane. We're going to number chlorine as 1, the ethyl group is 2, methyl group is 3. We are going counterclockwise, H coming out towards us. That means this is an R as well. So both of these molecules, these are the same, and this is R2-chlorobutane. So here we also have R2-chlorobutane, and this is just another way to write it out. This is 2-chlorobutane, but do we have R or S? Chlorine is 1, the ethyl is 2, methyl is 3. We are rotating counterclockwise with H coming out towards us, which makes this an R, so these are the same. R2-chlorobutane. Here we have chlorine, the ethyl, and the methyl. We are rotating clockwise, H to the rear. That means these are the same molecules. Here we have two alcohol groups. It's called a diol, and this would be 1,2-cyclohexane diol. They are cis to the ring. That means they are on the same side as of the ring. Well, so are these. So these are the same compounds. They are mirror images. This is a meso compound. This is a meso pair, as a matter of fact. They are superimposable mirror images. Number 58, we have a trans to the ring. So we have an OH above and an OH below, an OH below and an OH above. And although they are trans to the ring, they are not the same compound. Now, if you can mentally turn this over so that the OH, so that we mirror. So we have an OH coming out here, and here we have an OH receding. That's what we have. It's the mirror image here. I just turned the ring around. So any which way you flip this, what you have is a non-superimposable mirror image. These are enantiomers. These asymmetric centers are going to be directly opposite one another. So here we have, these are called diastereomers. You see, you have the same configuration for one of your asymmetric centers, but the other asymmetric center is going to be flipped. So these are diastereomers. Diastereomers occur when you have more than one asymmetric center, and they are not mirror images, but they are stereoisomers. For number 60 here, We have, let's see, we have mirror images. They are not superimposable. So what I'm doing is mentally kind of flipping it this way so that I can take and put this OH to the rear. And this guy comes out like this. So I've rolled it around so that this is the molecule. So it's a mirror image, but they are not superimposable. And because they are not superimposable, these are enantiomers. Now, another way to look at this is to take this and rotate it down a notch. And what I mean by that is to take the whole molecule and turn it about 60 degrees. And when you do that, you'll find that this molecule here is equivalent to this molecule here. It's the same molecule. So they are enantiomers. It's just different way to view it on the page. Here we have, in 61, we have 3 asymmetric centers. And without figuring out all of the asymmetric centers here, what I see is when I look at them, they're equivalents. This one's to the rear, this one's coming out. This one's to the rear, this one's coming out. This one's coming out, this one's to the rear. They are directly opposite one another. And because they are directly opposite one another, these are enantiomers. So here on number 62, we have coming out, pushed back, coming out. Again, all flipped, pushed back, coming out, pushed back. So immediately we would want to say they are enantiomers, but they're not. If I take this molecule and take it so that this OH is in this position, it's coming out. These are the same molecules. So this is a meso pair. They are achiral. And they are achiral. I should have seen that at the beginning because there is this line of symmetry here. So this is a meso pair. Here on number 63, let's see, we have, it might be easier if I'm going to name these asymmetric centers. So here I have chlorine is number 1, hydrogen is number 4, this part of the molecule is 2, and this part is number 3. I'm rotating clockwise, that makes this an R asymmetric center. Chlorine is 1, molecule is 2, methyl is 3. Rotating clockwise, this is also an R asymmetric center. So here I have chlorine is 1, molecule is 2, methyl is 3. I'm rotating clockwise, but the H is coming out towards me. So this is an S asymmetric center. Here I have chlorine is 1, molecule is 2, methyl is 3. Rotating clockwise, but H coming out towards me. This is an S. So for number 63, there we are. For number 63, we have enantiomers. For number 64, we start with the same molecule we had in 63. So I know that these are both R's. So now let's look at the other molecule. Chlorine is 1, molecule is 2, methyl is 3. We're rotating clockwise, but H is coming out towards us. So this is an S configuration. Chlorine is 1, molecule is 2, methyl is 3. We are rotating clockwise. Hydrogen is to the rear, therefore this is an R configuration. So we have 2 asymmetric centers, but they are not directly opposite. So these are diastereomer molecules. They're a diastereomeric pair. For number 65, I'm going to rotate around this bond here. And when I rotate around this bond, it starts to look like this, with chlorine coming out, hydrogen receding, chlorine coming out, hydrogen receding. So immediately, I know that this is going to be a meso molecule, but is it a meso pair? Well, if I rotate similarly around this bond here, I get chlorine to the rear, and I didn't draw that to the rear, but chlorine to the rear with hydrogen coming out. So chlorine, hydrogen. So if I take this and flip it around so that the chlorines are coming out, I have a meso pair. These are the same molecule. So this is a meso or same. Here for number 66, this molecule is this molecule. It's just a different way to show it. And this is what I had drawn. So if I rotate around this sigma bond, the chlorines come out. This is a meso pair. These are the same molecules. It's a meso pair. And number 67, again, we have a different molecule. We have chlorine to the rear, chlorine up front. So I'm going to name each of these asymmetric centers. Chlorine molecule methyl. So I'm turning clockwise with H to the rear. This is an R. So here's chlorine molecule methyl, turning counterclockwise with H coming out towards me. That means this is also an R. So here, chlorine, hydrogen, just as before, this is an R because it's the same asymmetric center as up there. So here I have chlorine molecule and methyl, and I'm turning clockwise, but H is coming out towards me, so this is an S. So this is a diastereomeric pair. These are diastereomers. And number 68 here, I'm sorry, number 69, I took 68 off. So number 69, we have our six-membered ring, our, that's what I was waiting for, our alcohol group coming up above the ring, alcohol above the ring. Here's the other alcohol above the ring, alcohol above the ring. These are the same molecules, so we have a meso pair here. And number 70, we have our alcohol group above the ring here, and on the adjacent atom, alcohol below the ring. So these are also the same molecule. We have a meso pair.